So as your NTSE exam is scheduled on Feb 5th, so I thought of giving you some information, giving you some content for your practice. Right? So this particular topic has already been covered. Once again, I'm just reiterating the facts. So if I have missed anything over in the class, or if I wanted to share anything that I couldn't show because of constraints, so I'm doing it in this form of video. Okay, so this particular topic, you call it as figure counting, or you also call it as figure partition as stated in your materials. Okay, right. So first of all, here what we are going to do today is finding the number of triangles. So how do we find the number of triangles? So for example, let us say this is one triangle. You all know I'm very good at drawing, so please adjust accordingly. So the number of triangles, so this if they give a diagram like this or a figure like this, the number of triangles are 1. And suppose if they are vertically partitioning, so now the number of triangles is 3. Suppose you have vertical partitions, 2 vertical partitions, the number of triangles is 6. Suppose they give you a diagram like this. Now the number of triangles are 10. Sir, how are you able to tell without actual counting? So that is the trick that we are going to learn now. Here there is only one partition, so one triangle. Here you have 2 partitions, so add the number of partitions. Also add the number of partitions over here. 1 plus 2 plus 3, 6. Here 1 plus 2 plus 3 plus 4, you will get 10 triangles. So this is for vertical partitions, vertical cut. You can say type 1. Right? Next, coming to horizontal cut. For example, let us say there is a triangle like this. As you already know, the number of triangles over here is 1. Suppose I draw a triangle like this and make a horizontal cut like this. Here there are 2 triangles. If I make a horizontal cut like this, now here there are 3 triangles. Sir, how are you able to tell 1, 2, 3? Very simple logic is the number of horizontal lines. So for horizontal cut, type 2, let us say. So for horizontal cut, number of horizontal lines will be equal to number of triangles. Number of horizontal lines will be equal to number of triangles. Now moving to the next type, type 3, a combination of both vertical as well as horizontal cuts. For example, let us say a diagram like this. How many number of triangles are there? Very simple. As you can observe here, this first portion has 2 cuts. The next portion also has 2 cuts. So add these number of cuts. So this total will become 6 number of triangles. Suppose I give you a diagram like this. Find the number of triangles. So once again here, if you observe, you have 2 partitions, 2 partitions, and 2 partitions in 3 layers. So add, you get 3. Add, you get 3. Add, you get 3. So total number of triangles would be 9. Right? Now, suppose I give you a diagram like this. Find the number of triangles. Now, if you observe how many number of cuts, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So in the first layer, you have 10 triangles. Second layer, 10, like that 10, 10, and another 10. So total number of triangles would be 50. So if you count, so this will take a lot of time counting, sir. If such a big diagram is given, right? So quite easily using this logic, you will be able to find that the number of triangles are 50. Next, suppose a triangle is given like this. This you call it as a grid triangle. Let us say this is a 3 by 3 grid triangle. See, you have 1, 2, 3, 1, 2, 3. So this is called a 3 by 3 grid triangle. So whenever you see a 3 by 3 grid triangle, the number of triangles, how do you find the number of triangles? Write the numbers 1, 2, 3 because this is a 3 by 3 grid. At the end of first row, you have only 1. Add 2, you get 3. Add 3, you get 6. Add these values, you get 10. And from the bottom to top, choose only the alternate values and add up. So the number of triangles would be 30. So if you find it difficult, you can just go back, reload it again, right? Next, suppose I give you a 4 by 4 grid triangle. Right, this is a 4 by 4 grid. See, 1, 2, 3, 4, 1, 2, 3, 4. So for a 4 by 4 grid, what do you need to do? Write down the number still 4. At the end of first row, 1, adding 2, you get 3. Adding 3, you get 6. Adding 4, you get 10. Add all these values, 20. Again, move from bottom to top. Take the alternate values. So 20 plus 6 plus 1, you will get 27 triangles in a 4 by 4 grid triangle. This is one more model. So like this, you can find for any number of grids. Add up the values, end up the rows, add, again add all the values and take the alternate values. Right? Suppose another model, type 5. Suppose I find a triangle like this with one triangle embedded inside. So whenever you observe this type of a figure, remember that the number of triangles are 5. Number of triangles are 5. Now let us see one example. Let us say there is a triangle given like this. So as I told previously, here if you observe this grid, this particular grid over here will have 5 triangles because a triangle is embedded inside it. So this is 1, 2, 3, 4, and the bigger triangle is your 5th triangle. Quite naturally, this is 6, this is 7, this is 8, and the bigger one is 9. Okay, so you are adding up number of triangles are 4. Suppose I give you a bigger diagram like this. Another triangle is embedded inside it. Now the number of triangles would be that. You can directly establish this. Suppose for the same diagrams, this is type 6. Now what happens? I am splitting up the triangles. So that means you are adding up another 6 triangles. So the number of triangles for this type of figure would be 11. Now for this same triangle, if you are adding up lines like this, so you are adding up by 6. So the number of triangles would be 15. Here in this particular case, it would become 90. Right? So these are the different models. Now suppose if they give you a square and something like this with the diagonals. Now, if they are asking you to find the number of triangles, all you need to do over here is count the number of parts, 4 parts, and multiply 2. So the number of triangles would be 8. Okay, suppose I am making the square into 8 particles and I want you to find the number of triangles once again. So how many parts are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 twos are would be 16. So the number of triangles are 16. Suppose I give you a diagram like this. Now I want you to find the number of triangles. How do you find? Very simple. See, you have a square with 8 parts. So that is quite naturally 8 twos are 16. You have another square inside that having 8 parts. So again 8 twos are 16. So the total number of triangles would be 32. Right? It's very simple and very easy learning. Then moving on. Counting of squares. Now when I say counting of squares, Nana, we have 2 cases once again here. Case 1. Number of rows are not equal to number of columns. So for example, let us say I am giving you a grid like this. Right? So my number of rows are 5 and my number of columns are 4. Right? So how do you find the number of squares? Very simple. Start with the maximum number of rows and columns, 5 fours. Reduce each row and column by 1 till you get 0. And add all these results. So my number of squares would be 40. Right? So in the same way, you can try for a 4 by 3 grid also. So if it is a 4 by 3 grid, what happens? 4 threes are, 3 twos are, 2 ones are, and 1 zeros. 12, 6, 2, 0. So number of squares would be 20 if it was a 4 by 3 grid. Right? Next, moving on. Case 2. If the number of rows is equals to number of columns, let us say I am taking a 3 by 3 grid. This is a 3 by 3 grid. All are squares. Please don't mind the drawing. Right? So this is a 3 by 3 grid. So my number of rows is equals to number of columns. What I need to do is I need to square the numbers. So 3 square plus 2 square plus 1 square till 3, because this is a 3 by 3 grid. So what will be the result? I will have 14 squares now. So no need to count, directly you can find the value. Suppose if they give you a 4 by 4 grid, what would be the result of a 4 by 4 grid? 1 square plus 2 square plus 3 square plus 4 square. So 1 plus 4 plus 9 plus 16, that would be 30 number of squares. Right? Also, few more interesting results. Suppose you find a square with a plus symbol. Number of squares, whenever you have a plus symbol, inside a square, the number of squares are always 5. This is one important result. Suppose we have something like this, then the number of squares would be 6. So using these results, we will be seeing few questions now. For example, let us say there is a 4 by 4 grid over here. Squares like this. I already told you it is a 4 by 4 grid. So 4 by 4 grid would have 40 squares. Sorry, 30 squares. I do commit mistakes. See, 4 square, 3 square, 2 square plus 1 square. I have done just now, right? So 16 plus 9 plus 4 plus 1, 30 squares. And if you observe, I have 4 such squares having plus symbol. Just now I told, whenever you find a symbol like this, number of squares are 5. So what happens? 4 5s are 20. So this is 30 and this is 20. So my total number of squares would be 50. Right, Nana? Right. One more question. Suppose I'm drawing a diagram like this. I want you to find the number of squares. As I have told you previously, this is a square having the peculiar symbol. So 6. This is another square having the peculiar symbol, another 6 squares. This is a square having a plus symbol. So my number of squares would be 17 squares. Right? It's very simple one. Right? Now, suppose coming back to last year's questions. So last year you had 2 questions of this particular model, and these examples are very, very useful to solve those type of questions. So your question, first question was like this. And they had mentioned in the question very clearly that all are squares. So no rectangles are there in this particular given question. Okay, now if you observe, Nana, over here, this particular small square over here, this is a 3 by 3 grid, right? As you all know. So for a 3 by 3 grid, the number of triangles would be, number of squares would be 3 square plus 2 square plus 1 square. That is 9 plus 4 plus 1. That is equals to 14 squares. Now, again, if you observe at the outer range, this is once again a grid which is 3 by 3. Right? 1, 2, 3. 1, 2, 3. So again, another 3 by 3 grid would mean 14 squares. And if you observe, you have one common square over here for both the grids. So you need to subtract that one. So the number of squares would be 27. Very, very simple question. Very, very easy question. Right? Of course, with options, it becomes more easier. The options given were 18, 27, 21, and 24. So with these options, easily you can identify that it is 27. Right? One more question was Here what we will do, instead of counting everything under, we will just use elimination method. See, observe. Question given is like this. Right. Options are 70, 11, 8, and 10. They are asking you to find the number of triangles. Now you know one thing for sure, that this particular thing, it is nothing but, sorry, this particular thing over here, this is looking like a square, and this is cut into 4 parts. So you already know that you have around 8 triangles over here. That is the trick which I had discussed, something like this, if you remember. Right. Now if you observe here carefully, already you have 8 over there. This is 9, 10, and 11, and this is 12. So you have already crossed 8, 10, and 11. So by the method of elimination, directly you can choose the answer as 70. So it's quite simple, right? So instead of actually counting what is happening over here, you are able to solve the questions, right? Hope this video helped. I'll try to give you some more information and data in the coming hours. Thank you. Thank you very much.